Okay, welcome to our February 2nd, 2019 structural modeling video conference. We have a couple of new administrative procedures associated with the video conference now. The first one is going to be the fact that I'm going to have an agenda that's posted in the front, so video, so people can identify areas they're interested in and kind of guide their way through the video without having to watch the whole video an hour's worth as you go through it. A couple of reasons for this. The first reason, of course, is that previously we've published papers, distributed those papers on a single topic to discuss during the video conference, and then posted, those papers on ResearchGate or other places. Now we're moving into an area where we're going to be integrating many of the techniques and concepts that were addressed in the previous papers. And we're also going to be reducing some of those concepts and ideas to software. So it's going to be kind of some of the time we're going to focus on how the reduction happens on papers that have already been published. Other times we'll talk specifically about the software format and the software methods that are used to implement those techniques. And then other times we'll be talking about other high-level concepts that we'll have published other papers on. So our meetings will start having a little bit more variety to them. So hence the agenda. And as I said, we'll go ahead and take a look at the GitLab here, introduce that in a minute. And the structural modeling logical basis, we'll cover that. These are basically the areas that are covered in the paper. We'll go through and talk about an expanded structural modeling approach, and then we'll have a summary and a wrap-up. But essentially, what we will do in the coming, like in March, we're going to have a paper and have a presentation that steps back up the level of abstraction and shows how many of these techniques fit together. Right now, we've been focusing on the logical pieces and how that would reduce in the software. But now we're going to step back up and talk about the big logical chunks and how they would fit together, and then how those would be integrated by teams and individuals to access the software in a manner that they don't get overloaded and they will be able to use effectively. Let's take a look at the paper now for today. Okay. And as noted in the presentation, we're dealing with some of the specific logical details of the software. We've established a repository for the software online. This is GitLab, which is an open source software support. I'm going to go ahead and share that with the group now so you can see that. There we go. Okay, so now this, I'm going to slowly introduce and slowly start integrating this. It has a lot of advantages for a team. People don't have to know how to use it, but people who do know how to use it and are interested in this area, it will be effective for them. And over a period of time, people might find that it's a good way to keep track of notes, issues, questions, or just as a central repository for information about this particular project. And over a period of time, people that are interested should be able to use this. You might tell I got a bit of a cold today, so we'll be moving through this. But the main thing to see here, and is just to point out, I was on the right-hand side, these icons have a number of things. And one of the important ones right here is the wiki. So there's a wiki associated with this. I've started to populate the wiki. And in the wiki, here on the main page, they talk about the augmented interactive management support software context. I have placed pointers here to the papers on GitHub, which are the high-level components. Then in the wiki, I've broken this down into the functions of the augmented interactive management. These are the types of functions generally that we'll be implementing in software. And of course, the objectives. And I'll talk a little bit about the objectives here. And then the library. So the first thing that we'll be doing is creating libraries that will implement these functions. So that's a general overview of how that works. So I'm going to now go back and stop sharing this. Go back and share the paper again. Okay. All right. Now let's go ahead and all right. So as we say here, we're going to start making distinctions between the different kinds of approaches that Warfield generated, UPP, the Unified Program Planning, Interpretive Structural Modeling, and Interactive Management. And to do this, I think it's necessary to start doing this and calling these distinctions because the things are a little bit confused. The names, the standard names are overloaded, and we want to be able to be very clear about what's going on. And so our structural modeling logical basis that we're looking at right now, is from what we can tell from our overview, there's two kinds of, the way that you use logical modeling or logic in these processes is you use it to increase the efficiency and reduce the cost by doing a logical analysis of what the subject matter experts have already told you. So you start with a situation where you have no information, you get empirical information from your subject matter experts, then you work your way up. So that's basically what we're looking at here in the application of the logic. The way that this is normally done is when you bring all of your subject matter experts together into a common room with the right support processes, then you optimize, well, you minimize the cost of the knowledge acquisition is essentially the process there. So this happens within a concurrent structural modeling workshop. And the classical approach is you have two types of questions. The first question, of course, is a triggering question. And the second is called a generic question. And so the triggering question is really created for the group so they can generate the objects to be a collection of items or objects to structure. And then the second question, the generic question, is used to help structure the items that have been produced. And of course, multiple workshops could be done in sequence. And one of the things that we found when we went through and were looking at these processes in detail is that first, there was no open source software, so we couldn't really see what was going on in the in the foundational concepts, the transforms, and that supported these techniques. So we wrote some open source software as a proof of concept, and we went through and started trying to verify and reproduce the published information. And we were able to do that with the proof of concept software for the methods that were published in the Appendix 2 of the Handbook of Interactive Management, which was encouraging. But what we found was that those examples were limited to a relationship that produced a strict order or produced clusters of equivalent things. And there's other generic questions that do not produce those types of structures, and we were unable to actually find a verifiable, reproducible method for that. So when we were looking at this and trying to figure that out, then we developed the augmented model exchange isomorphism, which creates 27 groups of logical attribute combinations that are used to cover the space of structuring the relationship logical attributes. And so we looked at those, and we found that there was really not many of these logical groups in the AMEI were directly addressed by Warfield or others in the area. So what we found is we had a scenario where we have both reproducible and non-reproducible types of system structures. Now, the question you need to ask in a specific context is a non-reproducible type of system structure useful? If you have a scenario where you have no idea what the structure is, right? And if you use a technique that's kind of non-deterministic and gives you a different answer each time, are those answers valuable? In some cases, I think the answer would be, the answer is yes, because at least gives you a way to start approaching it. You do it multiple times, you can talk about it, you have structured dialogue, you can do a number of things. So what we're trying to do, however, is see if we can find ways that are reproducible, and because essentially from a scientific standpoint, you need to have results that are verifiable. So this is one of the things that we've been working on, and that's why one of the reasons we're changing the structure a little bit and looking at it that way. So given an unknown system, is any structure better than no structure? Well, that answer to that, of course, is in a value system and is context dependent. And are there clear metrics to determine the value of any non-reproducible system structure? Well, again, context dependent. And so we need to figure out, well, are there other ways that we can, other techniques we can use that are reproducible and give us some insight into the system? So what we've done here, of course, is these are our 27 logical groups. And you'll notice that the green ones are the ones that produce the ordered structure or the equivalent clusters, and then the blue ones are the other ones that fill out the rest of what is transitive in the first column. And we found that the green ones were the ones that were mentioned in text in the Mathematics of Structure and other parts of Warfield's publications, but also he presented graphics that represented some of these other combinations in the first column. And one of the problems we have with evaluating these logical groups is just the convention of creating a structured graphic. So the convention for creating a structured graphic, convention is you do not put the transitive links on the graphic. If you did a graphic of any number of nodes, it would just clutter it up and you couldn't see the structure, and it'd be difficult to tell which were the symmetric links and which were the transitive links. And so the convention is you don't put those on the graphic. So then if we're looking at the art construct, which is the abstract relation type, which is used to represent the information in the augmented model exchange isomorphism, if you look at that, then you have the mathematics. So if you can take a mathematic matrix and you can read that, and then you can read the details in that, so that you really have prose, which you can name these logical structures, and then the structured graphics, which don't work on, don't represent the transitive piece, and then the mathematics piece, which do. So those three forms of languages together help give a better picture when they're integrated of exactly what's going on in the logical space. Okay. So as we talked about, these four figures that we have are addressed by text by Warfield. These groups are listed here. And then these groups are implemented in the software in Appendix 2 in the Handbook of Interactive Management. We have the do model, which is the most general command, and it can use on any structuring application. So it seems to me that these are limited to a few group types. And the do class, which creates symmetric clusters of things of the same kind, equivalent object properties, and do prior, which is used to order object classes. Now, the do prior, when you're ordering things, you can order them if you only have a single object in a class, or if you have multiple objects in the class. But these are the structural relationships that were presented in the GMU ISM software. So, as we said, we created a open source proof of concept software. And this software basically is used to, we used it to verify and reproduce the information that was given in Appendix 2. However, we were unable to verify information that was published from other sources, and or using other generic questions. So we looked at that, and again, as I said, that's kind of one of the things that's been motivating us to see if we can find something that is reproducible and a way to engage the system structuring approach in a more efficient manner, in a more predictable manner. And one of the things that's interesting about the naming convention that was in Appendix 2 is the fact that the do class basically is named on a structured graphics representation. And the do prior is based on the name of a specific natural language construct. So if we want to make these techniques universal and applicable to a wide range of structural modeling, natural language relationships, we need to find a way to have a more common naming convention. And what we propose in this paper is that we actually name these software functions based on the logical combination groups. And then, because that's going to be quite, it might be quite confusing for people, then we're going to use the ART construct, the abstract relation type, as a intermediary to translate those logical groups to any specific natural language relationship. But we haven't talked about that component very much, how you actually go from the logic through the ART form to interpreting this to a larger group of people that are not specialists in logic. But we will start introducing that material in March, in March 2nd, I think, conference. We're going to be, March 2nd, we'll start introducing a higher level of abstraction with these systems, a broader range, and then we'll start indicating where these specific techniques will fit, where we believe they'll fit in, what their roles are, large-scale system discovery, analysis, or design. And then we will talk about how some of these techniques that Mary and I have developed over the past few years would fit in. We haven't really, been talking about them recently, so we're going to be bringing those in and talking about them in more general type of architecture, functional architecture. But one of the things that we looked at this time was, did the natural language relationship that's used in the generic question, did it have a concept of equality? Did it have a concept of order? And so the natural language relationships, you can see here in this specific table, we ran through and listed what we believe are the answers to these questions. And the concept of order is important because if the natural language structural relationship has a concept of order, then we can use a number of standard computer science algorithms to address the software. So in our proof of concept software that we did to check the information presented in the handbook, we based all of that software on the matrix, on the binary matrix mathematics that was published by Warfield in the Mathematics of Structure. So in working with that, what we found was that the these specific relationships actually turned out to create orders, and we can use more advanced algorithms in the software to actually implement them. So our plan in the future is to actually do that. When we have an order, then we will be able to use binary search and ordering algorithms that are well known to computer scientists. So if they're not, so let's say what happens if we're working with a relationship that is not in order, then we're going to propose different types of software algorithms and methods to still manage the information and still achieve efficiency in the process, but it won't necessarily be logic-based like as presented in the mathematics of structure. We'll have other techniques we believe will be just as effective. So expanded structural modeling software methods, here what we talk about is the fact that we need to be careful about the translation and moving from a natural language relationship and assuming that the transitive piece always works. And again, the reports to natural language relationship is used as an example here. And because of the convention that you do not input the transitive has on your graphic, an intransitive chart, structured graphic, and a transitive structured graphic are going to look the same because they don't have those on there. And the AMEI, we put them on there. We put them on in different colors. We'll probably have to address and update that AMEI with a process where we'll have where you can make a distinction between them, and it's published in black and white, so you're not depending on the colors to know which is transitive and which is symmetric and which is reflexive. But we're taking the reports to natural language relationship and looking at it. And so what we have said if Sam reports to Pete, Pete reports to Sue, Sam does not report to Sue. So that's very logical. That's basically saying, okay, this is a process that's intransitive. So you really can't use the logic to update and get some efficiencies out of it. And so the two basic components of structural modeling is you getting the information. First, you're getting the empirical information from the group. So the group knows who, knows who Sam reports to. So you just ask the question, who does X report to? The group can tell you. You can't use the types of logical pieces to infer anything about this structure. So you just use the software to keep track of it. Also, we know that we know going into it, we have an organizational hierarchical structure. So we can get some benefits from that because we know about that. And then if we look at the idea, still the same kind of hierarchy, you say, well, who is next to X, right? And this is, again, an irreflexive, well, it's irreflexive and intransitive, but it's symmetric, where reports to is irreflexive, intransitive, and asymmetric. Now we have a natural language relationship that is irreflexive, symmetric, and intransitive. And next two basically is the same, or very similar to adjacent to, and as we talk about here later on, adjacent to has some issues in the way that it was introduced in the mathematics of structure. And now we're introducing this idea now here about near, okay? So near, we talk about a kind of scope transitivity. If I have a group of objects, depending upon what your definition of near is, you're going to have some objects that are near and some objects that are not. So some objects are going to have a near type of relationship that is transitive, and some objects are going to have a near type of relationship that's intransitive. And of course, when we say that you have a combination of transitive and intransitive, we call that non-transitive. We've gone through here and you show that these natural language transforms now have a direct relationship to natural language type of situation. And we can infer information from them. We just can't infer order at this time. It's not clear to us if we can infer order, but we can get some benefit from knowing the actual context and structure. Okay. So, as we say here in the augmented interpretive structural modeling examples, we're really going to focus on the ideas of, well, does our natural language concept have an understanding of equality? Or is it associated with the idea of order, right? Equality and order are the two things that we need to be able to use the classical logical approaches at this time in a reproducible way. So we look at that, and we decide how we're going to, work with those. So if we have the concept of order, and if we have the concept of equality, then we can use the logical software. And if we don't, then we can still apply some types of techniques. And of course, as we pointed out before, there are groups that use logical software in ISM, and there's groups that do not. So there's really kind of an overloading of the term ISM, and it means many different things to many different people. So in the augmented interpretive structural modeling, we're going to try to specifically name these groups, name these techniques, and provide a mechanism by which you can do ISM techniques by hand if you want. You can do it with software support that does not use logic, or you can do it with software support that does use logic. And right now, the AMEI allows us to evaluate the natural language relationship to determine whether or not that natural language relationship will create a reproducible structure. That's how we're making the distinction at this time, whether or not we use logical software or we use some other kind of software. Okay. So here we go through and say, well, now we're going to start naming all our software methods and all our approaches by the logic, right? Of course, one of the things that this does is that it then puts the technique and the name tags of the technique into a formal language, mathematics. And now you can have different natural languages, French, German, Spanish, Portuguese, Japanese, Indonesian, Arabic, whatever you want. Those natural language relationships, those words and relationships now can be mapped to these formal concepts. And so that's a technique, I believe, that's very powerful, and that would be, once these formal techniques and structures are put together, then as you're talking with people, they can map from their natural language to the formal language. And soon, sometime in the next 2 or 3 months, we'll present a question and answer type of structure that we believe would be valuable in doing that natural language relationship mapping from any natural language to the formal language. And it's fairly quick process. So I think that is, again, a very important and valuable part of this new expanded augmented interpretive structural modeling approach. Okay. So here's our four main methods that we put together, or four functions. Of course, reflexive, symmetric, and transitive. That's, oh, things are all the same. They're all the same category. We're creating groups, right? So we're creating clusters of objects. That's kind of what this logical relationship does. It says these things are the same. It's the logical signature for equivalence. And then irreflexive, asymmetric, and transitive. Okay, this one now is basically the logical signature for creating an order or a sequence, right? You say, okay, we go through and do these. We have we did this in a number of ways. The first way on our proof of concept, we went to basic binary matrices. Didn't use mathematical operators at all. Just used the matrix manipulation to show that, oh yes, using the graphics in the matrix graphics that Warfield did in the proof of concept, this will create an order. But once we know that, then we can say, okay, let's just use the software algorithms and computer science algorithms that are available for ordering. So I went back and looked, just once I figured this out, I went back and looked and said, well, when did binary search and ordering and so forth become, popular in computer science and published and things like that? And the mathematics of structure and the way that Warfield did it with the matrices and the development of binary searching and so forth were almost concurrent with each other in the literature. So that wasn't a technique that appeared to be well known when Warfield did this work. And so he achieved the same type of effect. But I think now using the standard computer science techniques will help communicate this to a much larger group of people that understand the algorithm. And then, of course, we have the irreflexive, asymmetric, transitive, and that's a group, an equivalent group or cluster of reflexive, symmetric, and transitive. No, excuse me, an irreflexive, symmetric, and transitive, which is an order, we're making an order or a sequence of reflexive, symmetric, and transitive, which is a group, okay? So now we're ordering a group of objects. And this is kind of important that these, two basic things can be fit together. And we can use the logic to figure out ordering, sorting, and do a number of things. Knowing now that this is a classical order, that gives us a lot of tools that are available from the theoretical computer science area. Okay, then document system structure. Well, in this particular case, it's like reports to, that's intransitive or non-transitive, like near. We can get some information from knowing parts of the structure, but we really can't use the straight ordering logic. We have to use other techniques. And of course, there's a lot of other techniques in computer science and artificial intelligence area. And next month in March, we'll lay the foundation for what we've developed so far can be used to support these more advanced techniques. And then a few months after that, that's kind of where we're going with this. We'll lay that out, how we can actually apply other things and integrate them to get a much better response. Okay, so these are the main areas of activity in developing the AISM software functions. And as I pointed out in the, when we looked at the GitLab, I'm going to write these as libraries. So I'm going to first start with a JavaScript library. And first I'm going to develop the whole system in JavaScript. And these will be JavaScript modules. This will be portable and plug and play within their infrastructure. Then later on, if we get into much larger deployments and much larger areas, then people may be concerned about the performance of JavaScript. So it would be very easy to make a translation over to Python or something that is much faster, probably Python libraries and a different type of backend that would support the front-end application. But these are the 4 types of libraries that were detailed on the wiki on GitLab, and that we'll start developing as we go further. Okay, okay, good. So we're running pretty close to, tracking pretty close to the agenda. I kind of wandered a little bit, but going pretty well. And the summary and conclusions basically is what we're saying is we've presented an array of improved and augmented structural modeling techniques. This is really an attempt to unify all the different approaches out there that use some that are done by hand, some that are done, with logical software, some that are done with, I don't know how, but there's a lot of different techniques. And so to bring this together and to identify them and say how they're same and how they're different, and just not call them all the same names. Because we have to be able to make some clear distinctions between the approaches if we're going to make any progress at all. And of course, there's a link to the GitHub, GitLab. Now, GitLab is a very interesting service. It's open source software, so it's free. It has, has your repositories, it has your issues, that people can log issues, you can track everything. It also has a continuous integration, continuous deployment, running a number of the more advanced types of techniques. We won't be going there right away. We'll just start using this a little bit, kind of introduce people to it. And the issues and the wiki and things like that where people can write. If anybody wants to figure out how they can put issues or talk, basically have access to the system, let me know. And I will give you the proper authorizations to be able to write and document and read and so forth. And keep, if you're interested in the details of how this is going on. So just let me know and we'll make that happen. So, given all that, it's now time for questions. Any questions?
Yeah, I have a question about the reproducibility. And this is, I know, an old issue for you because it's something you evaluated a long time ago. But as I understand, what you did was you looked at an existing diagram and you randomized the sequence of items you would ask the generic question of. Is that what you meant by reproducibility? If it would produce the same structure by randomizing it different ways?
Right. So what I did was I did a couple things. So for the proof of concept software, we needed to be able to test that, right? We needed to be able to test it to make sure that it was doing what it's supposed to do. So our approach there was, okay, well, when you use this tool, you use it on an unknown structure. We don't know what the structure is, right? But we use this tool, we use this technique, and then it creates a structure. Okay. So to test that in our proof of concept software, we created a structure. We know what that structure is, okay? And then we randomly generated that structure and then randomly sampled that structure, right? And brought it over and we're able to reproduce the structures that were clusters, strict orders, or orders of clusters. Okay? Those we were able to reproduce. Now, we also did this with the GMU ISM software, right? So we did our proof of concept software. We reproduced what the GMU ISM software did. Then we generated our tests, some other tests beyond what the GMU ISM software did. And said, yeah, okay, that makes sense. But then we went, to published representations like in the handbook and in the Science of Generic Design. And we started working on structures that were multi-threaded. They had more than one pathway through them, right? You notice that in the appendix where they tested GMU ISM software, there's only one main thread through there. Unless it's a clustering, and each cluster has its own main thread. But there's not multi-threaded. And so when we picked up a multi-threaded type of structure, we could not reproduce that. Right?
Reproduce it by changing. What are you changing that you couldn't reproduce it?
Well, say okay. So let's do it. So one of the ones I think was influence, and it had something to do with some group, some government, maybe a tribal Indian government or something like that.
Yeah.
And so it had nodes, right? It had 10 or 12 nodes, and these nodes were linked, right? And so if we look at that and we say, well, okay, we've got a triggering question, and what do we know? Well, we have these nodes. We don't know how these nodes are structured, right? But we have these nodes. Okay. So we take these, we look at the graphic, we eliminate the structure between the nodes, and we just take the nodes, right? And that's what I think you would have when you are done with a triggering question. Right? Have this group of unstructured objects or nodes. And then you just randomly pick one, right? And then you ask, right? Then you ask your question, does A affect B? Or does A influence B, right? And then you get a response. Well, those are the things that we could not reproduce the structure that we took those items from.
And to answer the generic questions, did you take the relationships that were in the published structure?
Yeah.
And then the software wouldn't reproduce the structure?
Right.
Yeah. So my question is, why is randomizing the order that you do things valid as, or reasonable to use as a means of validating reproducibility? Because that structure was created in a stochastic way, where each question that came up created a dialogue that led to more knowledge sharing amongst the group and could change the way that they would answer the next question.
Oh yeah, yeah.
So what you're randomizing, I see the randomizing the order as a way to verify an existing structure if the development of the structure was not stochastically dependent on the sequence of questions.
Okay, Kevin, that is really insightful. Okay, so let's break it down. What I think I heard you say. Okay, and so first of all, we have an activity where we start with no structure. Okay, then we perform a stochastic dialogue activity, and we produce a structure. And then once we produce that structure, we publish it. Right. Now, then is there value, right? Is there value and taking the software, right, that generated that asked the sequence of questions and generated that, is there value in taking that software and testing it by saying, oh, I'm going to take these objects, right, without any, I'm going to remove all the relationships because I already know what the structure is, right, and see if I can reproduce it, okay? Well, that static structure has already been reproduced, right? And so what I found, what it appeared to me, was that depending upon which question which object was addressed first, is then there would be another um, set of objects that were another object that was popped up for discussion, right? And then you would ask the next question and the next question and the next question. But in that case, there would be some objects that were never addressed because it was multi-threaded. So depending upon the thread of the object, if I randomly pick an object, right, pick it and say, oh, okay, it's going to be on a thread. And then things that are not on that thread, the questions don't appear to be asked. So that's kind of where it was. But we can go into that in more detail as we go forward because we will. We'll have to test this all again, and we'll go through and I'll expand that and explain it all and stuff.
Well, I mean, a simpler test of reproducibility is if you answer the generic questions in the same sequence as you did previously, does it produce the same structure?
Yeah, except yes.
That's a simpler test of reproducibility.
That's true, but they didn't publish that.
Yeah.
They just published the outcome.
Yeah.
So that's it. So, these are things that we will be addressing, right? And as we go forward and have a detailed discussion on, and I think they'll be valuable. Okay, so we have about 8 minutes left. Go back and do the summary and the wrap up here. So we've basically introduced kind of a new. Hello, Janet.
Hi. I was wondering about the triggering questions. Are they, how much effort, and maybe from Kevin's experience, goes into refining the triggering question in advance to ensure that you will be able to get reproducibility, or that you will get transitivity, or that it will be compatible with the generic questions, or is it left open to any possible triggering question, and then you struggle with it after it started?
I've been involved with 2 projects where development and testing of the triggering question went on for 8 to 12 months. Those were the longest ones.
Wow. Okay.
But I've also been in events where the person that was hosting and running the event made it up an hour before the event started and never tested it. And that I found uncomfortable and dangerous, but that was how they rolled. So, the triggering question needs it. The only way to there's not a body of literature about it. It's actually something I started working on and looking at what fields of study, such as survey development. Like there's a whole field of research and journals just about how to write questions for surveys, and they seem to know a lot more about how to ask a question than most other realms. But and they have a lot of techniques for testing reproducibility of the results of a question, meaning do people interpret the question in a similar fashion? But the more qualitative aspect of creating the questions, there's not a lot of literature from our people, from Warfield and Christakis. They say almost nothing about it. And you need to test it. You develop it. You typically come up with 12 or 20 questions, and you ask people questions in a small group and see how they answer. And you see, oh, when I use that word, it could be interpreted 2 different or 3 different ways. So I shouldn't use that word. I should use a more specific phrase. And you put that phrase out, and then you find out some other aspect of the question is confusing. And so you adjust it again. And it's a refinement process. And one of the nice things when you're doing big projects that involve people from around the country is this dialogue goes on over email, and it gets documented. All the when it goes over a period of weeks or months, you have dozens and dozens. And there's some projects where I've collected up the evolution of the triggering question and what the reasoning was and why it changed. But you can't make money doing that as a as a facilitator. It was something we were doing because we were on a big long project with the Air Force, and there was an interest by the person that was our host to really be refined about it, because we were bringing together a couple different directorates in the Air Force research labs, and they wanted to know there was this level of attention to it. But it's rare that you get the luxury of actually being able to turn the evolution of the triggering question into a research project.
Mm-hmm. That's very interesting. So some of the problems would be because of the specific knowledge of the cohort or cohorts that are being surveyed or that participate, that they might have different interpretations of domain language. And I'm wondering how much of it is generic, how much of the problematic issues in triggering questions might apply across modeling efforts, and how much would be specific to a given collection of people and their domains. That if there are generic issues, that would be really interesting to identify when you have time.
Yeah, if the context is clear to everyone, for most of what people use ISM for, they use it for planning or problem definition. So they say, if everyone understands the problem or the context in common, you can say, what's the problem? As the first triggering question, and you go through and you cluster and structure that, and then you say, what should we do about it? All right, but people don't know what the context is.
Mm-hmm.
They have different interpretations of the context, and getting a handle on the context in common can take up to a year.
Mm-hmm.
And then there's a lot of words that get thrown in by the people that develop it, especially if it's the facilitation team doing it. They put in words they think are fine, and it turns out they're politicized.
Interesting.
Words, and they have to use a more generic term. And
so you should have in your playbook at least some distilled wisdom on these things you just said in forming triggering questions. Maybe you do.
Well,
we should have a book on triggering questions.
That sounds really good. We're getting close to the last few minutes here. Anyone want to present on February 16th? Barry and I have March 2nd.
You have what?
March 2nd. March 2nd, you have March 2nd. But February 16th is open.
I think it'd be interesting to hear Janet's perspective and Ray, who's working with Ray, not David Ng. There's another fellow that's been on here about their perspective of, the potential role of Warfield's work and your work in how they see the future of NCOSE and the System Science Society and the linkage of these.
What do you mean, Peter?
Peter, yeah.
Peter, yeah.
Yeah, Peter and Michael and I are going to be at AAAS on the 16th. So we probably shouldn't commit to even attending. But yes, maybe we'll think about that for the mid-March session.
Cool.
Yeah, because this work was intended to be a great integrator.
Right. Well, one thing I can tell you that's new is that Michael and I have decided to run a workshop before ISSS in June that will cover some of the more mathematical aspects of GST. And we're still brainstorming that, but obviously this is a great aspect to include, is Warfield's work and matrix methods and what it does for you. Because we've just felt that ISSS has lost touch with the mathematical logical side that Boulding and Bertalanffy and everyone else originally saw. So
yeah.
Well, that's excellent. That's excellent. Okay.
Yeah. So I can take up for the next one.
Okay, Kevin. We'll get that ready, and if you have a topic, you'll let us know, and I'll publish that for the 16th, and we will continue to move forward. Thank you, everyone, for your attendance.
Very good. Thanks.
Bye-bye.